So here I'm going to talk about the solution for jump to 5. This is a solution. There's more than one way to write this for sure. Um, and the first thing that I had led you to was defining this jumper table. So we want to be able to say that 1 should go to 9. And I showed you the translation table here. 1 goes to 9, 2 goes to 8. Since it's a little bit tedious to type, I'm just going to highlight and copy this from my code. Um, put this in real quick. So that's the first few numbers, and here's the second bit. And over here, I'm just going to copy this into the REPL just so that we can verify. If I say jumper at character 1, it's going to tell me 9. If I say 5, it's going to tell me 0. But if I say, for instance, A, it's going to create an exception. One of the things that I talked about in the introduction was not ever using this pretty much, and instead using the get method. Here though, get, well, let's look at getting the value for 1, it gets 9, the value for 5, it gives me 0, and the value for A, it gives me nothing. Well, I want to be able to use that default value here. If I say get character A, and if it's not found, just give me the character A, and it returns A. That right there is crucial to the way that I went about solving this problem. So I have my jumper table here, and what I want to say is for each character in the text, jumper get that character, and if it's not found, then just give me the character. Give me the character back. And if I run that, that should work. That's really the whole solution, and I can run make test to ensure that it actually passes. So that's really the whole program right there. It's an amazingly short program once you understand how to use a dictionary. So we can look at, let's see if this is correct for the way I wrote that. So that's how I wrote this first solution. And we can look at this other solution. What did I do here? So another way to write this would be to define, and I can write it here. I can define, for instance, a new text, which is going to be some an empty string. And one of the things I don't like about the solution is that I print over and over again, and I have to say end equals, and I think that's a little ugly. Instead, what I'd like to do is build up a new string that I'm going to print at the end. I'm going to print new text here at the end. And I want to set new text. I want to add to it. And so I can use plus equal operator, the plus equal operator, and it's going to add whatever is returned by jumper to new text. If I run this, which passes all of my options there, it works just fine. Let me make sure that's exactly what I wrote. Yes. So this is another solution that builds up a new string. The string starts off as an empty string, and I iterate through each character in text, and I add to new text the thing that's returned from jumper by calling get for this character. And if that character is not found in this jumper table, then just return the character itself. And now I'm left with one print statement. And that I like a lot better. I believe solution 3, yes, solution 3 is the same idea, but instead of this being a string, I could start off with this being an empty list. And I can actually use exactly the same plus equal operator to add this thing to this list. If I run this as is, it's going to print the representation of a list. So it's stringifying that list. That's not what I want. If this is going to be a list, then I need to create a new string from that, which I can do by joining on the empty string. The empty string is just quote, quote. And if I run that, then it prints this. So this is really extremely equivalent to the string version, whichever way that you're comfortable working with. But it's interesting to note that the plus equal works with both strings and lists. So that's another way to write this. Solution 4, actually, let me show you just a slight alternate way. Yes, this version shows you using append. So another way to write plus equal is to call the append method. And so we're appending jumper get char jar to this, and it's exactly the same. And now I can run make test, and I see that it still passes all my tests. So plus equal works for both strings and lists. Dot append is a specific method for lists. Um, the fourth solution introduces something called a list comprehension. So if you understand the for loop, if you understand for char in text, we can actually write this a little bit differently. And one of the things I don't like about them is that they're a little bit backwards, but I could say new text is equal to this list that I'm going to create. And I start off by saying for char in text, but that actually comes at the end. So if I just said char for char in text, and right now I'm going to go comment this out. If I do this, I'm just going to build up new text is going to be exactly the same as the old text. This breaks because it's not changing the text. I don't want char. What I want is jumper get char and then char for char in text. So it's exactly the same code, but just jumbled around a little bit. If I run that, that works. And I run make test, and I see it passes all my tests. So this is a way, a list comprehension is a way of writing a for loop in essentially one line of code. So one of the things I really like about this is that here, these three lines have been compressed into one line, and new text is only mentioned once. It's just created here. So this version relies on what we call side effects. So I'm calling this method append on new text, and the side effect is that this new text gets mutated. I really tend to try to stay away from mutating variables as much as possible. Here, what I'm doing is in one line of text creating an entirely new variable built from the original text that we have here. So to me, this list comprehension is just a very clean solution. And the last way that I show you here, this is just a really, really wonderful way to solve this in one line of code. And it's using the translate method of, of the string class. And let me show you how that works. So what we want, we need to be able, what translate wants is essentially our jumper table. It wants a list of I want to change this letter to this other letter. And that's exactly what the jumper table creates. To understand it, we have to understand what is returned by string make trans. So if we go over here and we call string make trans on this, it's showing us that it's creating this table that all of a sudden has all these numbers in it. What are these numbers? Well, we're going to talk about this more later, especially in the program called Gematria. But this 49 is actually the ordinal value of the character 1. And so if I say, what is the character for 49? Then it tells me it's the character 1, not the number 1, but the Arabic numeral that we use to represent that value. So I can actually look up that ordinal value by calling the ord function on the character 1, and it tells me 49. So what maketrans does is it returns a new dictionary that gives me the lookup, the value from an ordinal value of some character, and then what it's going to be translated to. So the 49, 50, 51. Each of these are the characters that are going to be translated by our string make trans, by our translate method. So the return from this, we can capture this into a trans table. And now I can call, for instance, let's take our string here that we're using. What have I been using? This string. And I can say dot translate using this trans table, and it flips all of the digits around for me. So that's what this is doing. I'm just putting it all in one line, string make trans with the jumper table, passing that as the argument to translate. There's one other method that you might have been tempted to try, and that is the replace method. So given text that's going to be equal to uh, this value, let's say I were to try to say text replace 1 with 9. And you see that it went and replaced the 1, which was at the beginning, with a 9. Well, what happens when we get to we go through all the pairs and we want to replace 9s with 1, like this? Now we've changed the first 9, they got changed back into 1, and then the 9 that was in this position got changed to 1 too. That's not what we want. What we want is the number that comes out should be 98760432115, and it comes back, that 9 got changed back to a 1. So you might have been tempted to think that you could go through each one of the key value pairs and call replace on the text and accumulate those modifications, but that actually won't work, which is exactly why the translate method exists, is to be able to do that all at once. So that is, those are a number of ways that I solved the jump to 5. If you have a significantly different solution, I would love to see it. And thanks for your time.